Hello my dear students, in the last class I explained about thermal stresses and strains. Today we will discuss about thermal stresses in bars of varying section. Let us consider a bar ABC fixed at its ends A and C and subjected to an increase of temperature. Okay, let us consider here this is the bar and it is fixed at its ends A and C. Now L1 is the length of the portion AB and L2 is the length of the portion BC, and sigma 1 is stress produced or induced in the portion AB and sigma 2 is stress induced in the portion BC. Okay, A1 is cross sectional area of the portion AB and A2 is cross sectional area of portion BC. Alpha is coefficient of linear expansion and T is increase in temperature. Now, we know that result of the increase in temperature, the bar ABC will tend to expand, right? If the decrease in the temperature, the bar will tend to contract. But since it is fixed at its ends A and C, therefore it will cause some compressive stress in the body. Now, it is fixed at its ends E, so stresses are developed in the body. As the thermal stresses is shared equally by both the portion, therefore how you can write sigma 1 A1 is equal to sigma 2 A2. Okay, that means how you have written P1 is equal to P2. As the thermal stresses is shared equally by both the portion, means P1 is equal to P2. How you can write P? Stress is equal to load divided by area. So P is equal to stress into area. So sigma 1 A1 is equal to sigma 2 A2. Moreover, the total deformation of the bar means it is assuming that it to be free to expand. Total deformation is here I have considered two sections, so deformation delta L1 plus delta L2. How you can write delta L? Delta L is equal to delta L1 plus delta L2. What is delta L? Delta L is equal to PL divided by A into E. P divided by A is equal to sigma. So, P1 divided by A1 is sigma 1. Sigma 1 into L1 divided by E plus sigma 2 into L2 divided by E. Okay, if you take E outside, sigma 1 L1 plus sigma 2 into L2. Sometimes the modulus of elasticity is different for different sections. In such cases, the total deformation is given by delta L is equal to sigma 1 L1 divided by E1 plus sigma 2 L2 divided by E2. Okay, all these things you know, you have studied in the previous chapters. Okay, let us solve one example. A steel rod ABC is firmly held between two rigid supports A and C as shown in figure. Find the stresses developed in the two portions of the rod when it is heated through 15 K. Take alpha is equal to 12 into 10 raised to minus 6 per K and E is equal to 200 GPa. Okay, this is the bars of varying section. Two sections are there, A to B one section and B to C other section. A to B, that is L1 is 500 mm and L2 is 800 mm. What is area? A1 is equal to 400 mm square and A2 is equal to 600 mm square. Temperature is given, that is 15 Kelvin. Okay, alpha, that is also given 12 into 10 raised to minus 6 per Kelvin and E is equal to 200 GPa, that is equal to 200 into 10 raised to 3 Newton per mm square. Now let us assume sigma 1 is equal to sigma 1 is equal to stress developed in the portion AB due to increase in temperature, and sigma 2 is stress developed in the portion BC due to increase in temperature. Okay, what we have to do, since the thermal load is shared equally by both the portions, therefore stress developed in the portion AB, that means what I have told in the theory, that is sigma 1 A1 is equal to sigma 2 A2, right? Because the thermal load is shared equally by both the portions, so P1 is equal to P2. How you can write stress in term P means P is equal to load divided by area, right? Stress is equal to load divided by area. So load is equal to stress into area. So now sigma 1 A1 is equal to sigma 2 A2. So how we can write sigma 1, that is equal to A2 divided by A1 into sigma 2. I think I'll write this. Why it is sigma 1 A1, that is equal to sigma 2 into A2. Okay, I'll write in terms of sigma 1. So sigma 1 is equal to A2 divided by sigma 2 into A2 divided by A1. Okay, that's why it is written like this. So now substitute the values. You know A2, that is equal to 600 and A1 is equal to 400 into sigma 2 we don't know, so that is equal to 1.5 times of sigma 2. So sigma 1 is equal to 1.5 times of sigma 2. Okay, next is, we know that free expansion of the part 1 due to increase in the temperature. We know the deformation is given by, if there is a temperature change, delta L1 is equal to L1 into alpha into T, right? What is L1? L1 is 500 into alpha is 12 into 10 raised to minus 6 and T is 15. It is given. So calculate what is delta L1 and delta L2, that is L2 alpha into T. So L2 is 800 and alpha is 12 into 10 raised to minus 6 into 15. You get this. So total deformation or total expansion of the rod is equal to delta L is equal to delta L1 plus delta L2. What is delta L1? Delta L1 is 0.09 plus delta L2 0.144. You get delta L is equal to 0.234. This after this, what you have to do, now let us assume a compressive force to be applied at A and C, which will cause a contraction of 0.234 mm of the rod. Because of the increase in the temperature, the compression force is developed, okay, at A and C, which causes the contraction of 0.234 mm of the rod. So now means it is equal to the expansion. Therefore, you substitute that deformation total deformation is 0.234. This is equal to sigma L1 divided by, means what is this actually? This is total deformation. Total deformation is equal to delta L1 plus delta L2. Right, here delta L, what is delta L? Delta L is equal to P into L divided by A into E, correct? Here delta L we already calculated, delta L1 plus delta 2, that is equal to 0.234. Now you write this in terms of this equation. How you can write? So P by A, that is nothing but, P by A is nothing but sigma, correct? Sigma, this is suppose delta L1, sigma 1 L1, okay, divided by E. And what is delta L2? So that is sigma 2 L2 divided by E. Okay, here actually E1, this is E1 and this is E2, and here E is same, so you can take it outside. Therefore it becomes if you take it outside, 1 by E is equal to sigma 1 L1 plus sigma 2 into L2. Okay, that's why I have written here for that, because of this. Okay, so now E, you know, that is 200 into 10 raised to 3, substitute, and into sigma 1. Sigma 1 is what we derived that relationship. Sigma 1 is equal to 1.5 times of sigma 2. So substitute that 1.5 into sigma 2 into L1 is 500 plus sigma 2 we don't know into L2 is 800. Simplify this, you get this in terms of sigma 2. So only one one unknown, so you can calculate what is sigma 2. Sigma 2 is equal to 0.234 divided by 7.75 into 10 raised to minus 3. So you get 30.2 Newton per mm square or 30.2 MPa. So once if you know sigma 2, you can calculate sigma 1. Why? How? That is equal to 1.5 times of sigma 2, that is 1.5 into 30.2, that is equal to 45.3 MPa. 45.3 MPa. So like this you can calculate the stresses developed in the bars of varying section when it is subjected to the temperature. Okay, I think all of you now understood. Main thing what you have to do, first you have to apply that condition, thermal load is shared equally by both the portions, so that is P1 is equal to P2. Okay, P1 is equal to P2 is sigma 1 is equal to sigma 1 A1 is equal to sigma 2 A2. Substitute and simplify and write in terms of sigma 1. Okay, then next you have to find deformation that is due to temperature. Okay, you have to use this formula L1 into alpha into T, and then for deformation for the bars 2, L2 into alpha into T. So simplify this and you get the total deformation. Once if you get the total deformation is equal to delta L1 plus delta L2, right, in terms of sigma 1 L1 divided by E1, and then only one unknown you have to calculate, that is sigma 2. Once if you get sigma 2, you can calculate sigma 1. So in this way you can find what are the stresses developed in the bars of varying section. Okay, you just take this one assignment and solve yourself, and we'll discuss these answers in the next class. Okay, thank you.